Have you ever wondered what would happen if the Earth's size changed? Let's start by exploring the gravitational consequences. One of the fundamental laws of physics tells us that gravity is directly proportional to mass. So, if Earth's size were to increase, its mass would also go up, resulting in stronger gravitational forces. Imagine feeling heavier, with every step requiring more effort than before. Conversely, if Earth's size were to decrease, its mass would likewise shrink, leading to weaker gravity. Imagine feeling lighter, with each leap carrying you further than you'd expect. But gravity doesn't just affect us. It also influences the atmosphere's ability to retain gases. A planet with stronger gravity might hold onto its atmosphere more tightly, potentially leading to denser air and possibly even changes in our weather patterns. So, as we can see, a change in Earth's size would lead to a significant shift in gravitational forces, impacting everything from our weight to the air we breathe. Now that we've uncovered the gravitational effects, let's dive into the geological and atmospheric impacts of changing Earth's size. Imagine if our planet's size were to increase. The internal pressures could intensify, leading to heightened tectonic activity. The Earth's crust, made up of large plates that float on the semi-fluid layer beneath, would experience more stress. This could result in more seismic activity, including earthquakes and more volcanic eruptions. On the flip side, a smaller Earth might see a decrease in such activities, leading to a less dynamic geological landscape. But that's not all. A size change would also cause shifts in sea levels and land distribution. Picture this: with an increase in size, the mass of the Earth would redistribute, potentially causing sea levels to rise. Coastal regions could face inundation, altering landscapes and affecting ecosystems. On the other hand, new land masses might emerge, opening up unexplored territories. Now let's consider the atmospheric consequences. With a change in Earth's size, the atmospheric circulation patterns could witness significant shifts. Changes in gravity and atmospheric density could affect global wind patterns, leading to alterations in weather systems. Areas that were once temperate might transform into regions of extreme climates, while arid zones could become more hospitable. And what about the climate? Well, it's intricately connected to the size and composition of a planet. A larger Earth could potentially experience a more stable climate, with slower temperature fluctuations. However, a smaller Earth might face a greater climate variability, with more pronounced extremes. So you see, a change in Earth's size could bring about profound alterations in our planet's geological and atmospheric conditions. It would not just affect the physical structure of the Earth, but also the weather systems that we know and rely on. The weather patterns we're accustomed to, the landscapes we're familiar with, and the climate we've adapted to, all could undergo significant transformations. Therefore, a change in Earth's size would not only affect our planet's physical structure, but also the weather systems we rely on. Beyond the physical and atmospheric changes, what would be the ecological ramifications and astrophysical considerations of a size change? Let's start with the ecological implications. As gravity, temperature, and sea levels shift, life on Earth would need to adapt or face extinction. Species that thrive in the current conditions may find themselves struggling to survive in the new environment. Ecosystems would undergo dramatic transformations, leading to a reshuffling of biodiversity. Some organisms might find new niches while others might disappear entirely, leaving a radically different world in their wake. And what about us? Human civilization would face immense challenges. Coastal cities might need to relocate due to rising sea levels, and agricultural practices could be disrupted as crops adapted to specific climates struggle to grow in new conditions. Our infrastructure, designed for a specific gravitational environment, might need significant modification to function in a world with altered gravity. But the consequences wouldn't stop at Earth's atmosphere. Changes to our planet's size could also have far-reaching astrophysical implications. Our orbit around the Sun, for instance, could be affected. Changes in gravitational forces might lead to shifts in our orbital parameters, potentially altering the length of a year and the rhythm of the seasons. These changes could, in turn, have cascading effects on our planet's climate and ecosystems. And let's not forget our celestial companion, the Moon. The Moon plays a critical role in Earth's gravitational dynamics. Changes in Earth's size could impact the Moon's orbit and vice versa. This could result in variations in tidal forces, influencing everything from ocean currents to the behavior of certain species. In conclusion, while a change in Earth's size is a fascinating concept, it would bring about a cascade of effects that would significantly alter life as we know it. From the smallest microorganism to the largest cities, from our local weather to our orbit in space, everything would change. And these changes serve as a reminder of how finely tuned our planet is and how delicate the balance of life truly is.